amin pong i-discuss is about ferrous and non-ferrous metals. Pero before that, ay atin muna pong itakal kung ano ang metals. Metals is a material that is typically hard, opaque, shiny, and has good electrical and thermal conductivity. It is generally malleable, that is, they can be hammered or pressed permanently out of shape without breaking or cracking, as well as fusible, which is able to be fused or melted. And ductile is able to be drawn out into a thin wire. Para po mas maintindihan po natin, ito po ang classification graph po ng metals. Kung makikita po natin is, ang metals po ay divided into two sections, which is the ferrous and non-ferrous. Sa ferrous po, nandun po ang cast irons at saka po ang steels. And steels po ay divided din po sa two sections, which is low alloy and high alloy. Sa high alloy po, nandun po ang stainless steel, and sa low alloy naman po ay nandun po yung low carbon, medium carbon, and high carbon. Ferrous alloys are those of which iron is the prime constituent. They are produced in larger quantities than any other metal type. They are especially important as engineering construction materials. And its widespread use is accounted for by three factors. One, iron-containing compounds, which exist in abundant quantities within the earth crust. Metallic iron, padalwa po ay metallic iron and steel alloys, which may be produced using relatively economical extraction, refining, alloying, and fabrication techniques. And lastly, ferrous alloy, which are extremely versatile in that they may be tailored to have a wide range of mechanical and physical properties. One of principal disadvantage po ng ferrous alloy is its susceptibility or sensitiveness to corrosion. Katulad nga po nung nakita nyo sa diagram kanina, ferrous alloy is divided into two sections, which is cast iron and steels. And steels are iron-carbon alloys that may contain appreciable concentrations of other alloying elements. There are thousands of alloys that have different composition and or heat treatments. The mechanical properties are sensitive to the content of carbon, which is normally less than 1.08%. Meaning po as ang steels po ay very sensitive po sa content of carbon or highly dependent po sa content po ng carbon. So, sa carbon steels po, yun nga po. So, ang steels po ay classified according to their carbon concentration, namely low, medium, and high carbon types. Sa low carbon steels po, it contains less than 0.25% of carbon. It is not very responsive to heat treatment, and strengthening is accomplished by cold work. And it is soft, weak, tough, ductile, machinable, weldable, and compared po sa ibang carbon steels po is it is not expensive. And typically, it have a yield strength of 275 MPa or 40,000 PSI. And its tensile strengths between 415 and 550 MPa, which is 60,000 and 80,000 PSI. And its ductility is 25%. And mostly, ang application po nito ay sa automobile body components, structural shapes, and seats po. And sa low carbon steels po ay nandoon po ang high strength low alloy steels. Sa high-strength low-alloy steels po, it contains alloying elements such as copper, vanadium, nickel, and molybdenum in combined concentration of greater than 10 weight percent. So, compared po dun sa low carbon steels, dun sa plain low carbon steels, high strength low alloy steels po is stronger than the low carbon steels. And it is strengthened by heat treatment, giving tensile strengths in excess of 480 MPa or 70,000 psi. Compared po dun sa plain low carbon steel, which is makikita po natin na ang strengthening po niya ay ma-accomplish by cold work. Yeah. And high HSLA or high strength low alloy steels are ductile, formable, and machinable. And it is more resistant to corrosion than plain carbon steels. Yan. Next naman po is the medium carbon steels. Medium carbon steels po ay it contains 0.25 to 0.60 weight percent of carbon. And compared po sa low carbon steels, it is stronger but it is less ductile and less tough. It may be heat treated by austenitizing, quenching, and then tempering to improve their mechanical properties. It can only be heat treated in very thin sections and with very rapid quenching rates, but with the addition of chromium, nickel, and molybdenum, it will improve the capacity of this alloy to be heat treated. And mostly its application includes railway wheels and tracks, gears, crankshafts, and other machine parts and high-strength structural components, calling for a combination of high strength and wear resistance and toughness. Wait lang po. Yan. And next po is the high carbon steels. High carbon steels have a carbon content between 0.60 and 1.4 weight percent. And it is hardest, strongest, and yet least ductile of the carbon steels. And they are almost always used in hardened and tempered condition, wear resistant and capable of holding a sharp cutting edge. The tool and die steels are high carbon alloys usually containing chromium, vanadium, tungsten, and molybdenum. These alloying elements combine with the carbon to form very hard and wear resistant carbide compounds. And these steels are used as cutting tools and dies for forming and shaping materials, as well as in knives, razors, hacksaw blades, springs, and high-strength wire. And lastly po is stainless steels, which is within the high alloy. And stainless steels are highly resistant to corrosion or rusting in a variety of environments. Mostly po sa ambient environment po. And its predominant alloying element is chromium, and its concentration is required at least of 11 weight percent of chromium. And it is divided into three classes on the basis of the predominant phase constituent of the microstructure, which is martensitic, ferritic, and austenitic. And martensitic stainless steels are capable of being heat treated in such a way that martensite is the prime microconstituent. Additions of alloying elements in significant concentrations produce dramatic alterations in the iron to iron carbide phase diagram. For austenitic stainless steels naman po is austenite face field is extended to room temperature. The austenitic stainless steels are the most corrosion resistant because of the high chromium contents and also the nickel additions, and they are produced in the largest quantities. And lastly po is ferritic stainless steels, which are composed of the alpha ferrite phase. And kung i-compare po natin ang ferritic sa martensitic at austenitic and ferritic stainless steels are hardened and strengthened by cold work because they are not heat treatable, which compared by which is compared sa martensitic. And both martensitic and ferritic stainless steels are magnetic compared to austenitic, which is not magnetic. Yan. And its equipment employing the steels includes gas turbines, high temperature steam boilers, heat treating furnaces, aircraft, missiles, and nuclear power generating units.
So after the discussion of steels, we'll be going to I'll be discussing the other type of ferrous metals, which is the cast iron. So cast iron is iron carbon alloys that contains more than 2.14% weight percent of carbon theoretically. Pero usually po, it contains between 3.0 to 4.5 weight percent of carbon. So it passed through the eutectic reaction during solidification. So yung eutectic reaction po is when yung liquid po through the cooling process po, it forms a two solid materials po. Is which po yung one of the solid materials po na napo-form is either graphite po or cementite. So yung it depends po kung how paano po yung cooling process na nangyayari. Doon po nagde-depend yung formation po ng cementite and graphite. Then properties po ng cast iron is have good fluidity, become liquid easily at temperatures between 1,150 degrees Celsius and 1,300 degrees Celsius, readily castable, inexpensive, machinable, and wear resistant. So there are five common types of cast iron, which are gray iron, ductile or nodular iron, white iron, malleable iron, and compacted graphite iron. So ano nga ba yung pagkakaiba-iba nila and yung application nila? First po is yung gray iron. So gray iron is the most common and widely used type of cast iron, characterized by the formation of graphite. So yung ano po niya, graphite formation niya po is pointed and sharp end graphite graphite plates. So dahil po dito, it is comparatively weak and brittle in tension. Pero po, good po siya in terms of strength and ductility under compressive loads kasi po yung graphite acts as a cushion or sponge na nag-absorb po ng compression energy. It is also very effective in dumping vibrational energy. It also exhibits a high resistance to wear and least expensive of all metallic materials. So yung properties niya po is high compressive strength, good machinability, good resistance to sliding wear, good resistance to thermal fatigue, good thermal conductivity, and good vibration dumping. From the properties po niya, so since it is high stiffness nga po yung machinability po niya, so vibration dampening and high heat capacity and high thermal conductivity. So yung application niya po is wide po. So yung damping vibrational energy po is a base for machine and heavy equipment. So high resistance wear and high fluidity at casting temperature. So intricate shapes, so low casting shrinkage allowance po. Then yung tensile strength niya is 120 to 300 megapascals. So yung more on sa ano po siya ginagawa is yung products po is more on sa small cylinder blocks, cylinder heads, pistons, so liners, clutch plates, transmission cases, so gear flywheels, water pipes, engine, cylinders, brake discs, and yung machinery beds po. Going to the second type of cast iron is the ductile or yung nodular iron. So yung ductile or nodular iron contains spheroidal graphite particle. So inoculate with Ce or magnesium or both cases causes graphite to form as spherulites rather than flakes. So yung addition po yung adding po of magnesium or cerium is para po uh, prevent po yung formation of graphite flakes during the slow cooling of the iron po. So it is also known nga po na as spheroidal graphite or nodular graphite iron. Uh, Stronger and far better ductility than gray cast iron and has mechanical characteristics approaching those of steel po. Then yung steps po yung sa fabrication po ng ductile or nodular iron. So first is yung desulfurization. So yung calcium oxide is used po to remove sulfur and oxygen from the liquid. Then nodulizing po. So yung magnesium is dilute form po or magnesium ferric silicon alloy is added po. Residual of 0.03% of magnesium po must be present after treatment in order for spheroidal graphite to grow po. So yung application po ng ductile or nodular iron is on valves, pump bodies, crankshafts, high strength gears or heavy duty gears po and machine, rollers, slides, dyeing material having high strength and high ductility po. So the third type of cast iron is the white iron. So white iron features promoting formation of cementite over graphite. So a low carbon equivalent and rapid cooling po. So low silicon cast irons containing less than 1.08% of silicon po. It is hard, brittle alloy containing massive amounts of Fe3C or yung cementite nga po. Then, the procured surface of this material appears white, kaya po siya tinawag na white iron. And the group of highly alloyed white irons used for hardness and resistance to abrasive wear. So no graphite kasi nga po carbon forms cementite or more complex carbides. Very hard and very resistant surface without high degree of ductility po. So yung properties niya po so abrasion resistant, white procured surface extremely hard but also very brittle. So yung kaya pong na-form yung cementite is because of rapid cooling rate po. So yung most of the carbon po in the cast iron consists of perlite and cementite. So yung application po ng white iron is mostly on brake shoes, shot blasting nozzles, mill liners, crushers, pump impellers, and other abrasion-resistant parts. So where resistant surface, example as rollers in rolling mills, generally white iron is used as an intermediary in the production of yet another cast iron is the malleable iron. Ayan. Malleable iron is formed by the heat treatment of white cast iron po. So heating white iron at temperatures 800 degrees Celsius to 900 degrees Celsius for a certain period of time po at a neutral atmosphere. So para mag-prevent po ng oxidation causes a decomposition of the cementite So forming a graphite in form of clusters or rosettes surrounded by a ferrite or pearlite matrix depending on the cooling rate po. So yung mechanical characteristics of malleable cast iron is similar to nodular cast iron and give higher strength and more ductility and malleability po. So yung production steps naman niya po niya is first stage graphitization. So cementite decomposes to the stable austenite and graphite pieces. So second stage po, graphitization, slow cooling through eutectoid temperature to make ferritic malleable iron po. So yung most of the application po of malleable iron are connecting rods po, transmission gears, and differential cases for automotive industry, and also flanges, pipe fittings, and bulb parts of railroad, marine, and other heavy-duty services po. So parts of train vehicles, bearing cups, steering gear, housings, agricultural equipment, and railroad equipment po. So lastly is the compacted graphite iron po. So carbon exists as graphite and then yung graphite po the graphite in CGI or yung compacted graphite iron nga po allows alloys has a worm like or vermicular shape po. Then yung magnesium and or yung cerium po is also added po. But yung concentration niya po ay lower than uh, ductile iron. So yung and contains rounded but interconnected graphite also produced during solidification po. And then because of yung increase po ng degree of nodularity po of the graphite particles, naglilis po siya sa enhancement of both strength and yung ductility po na that exceeds those of gray cast iron but allows the iron to retain good thermal conductivity and vibration damping properties po. So in addition po, uh, ducti- ductilities po ng CGIs are intermediate between values of ductile gray and ductile irons po. Then yung moduli of elasticity niya po range between 140 to 165 gigapascal and PSI. So yung properties niya po is higher thermal conductivity, better resistance to thermal shock, lower oxidation at elevated temperatures po. So yung compacted graphite iron po, yung application niya po is more on sa diesel engine blocks, exhaust manifolds, gearbox housing, brake discs for high-speed trains, and flywheels po. So yan po, ito po is yung typical chemical compositions po of cast iron types po. Yung cast iron types po, so white, gray, malleable, ductile, and graphite nga po. So may mga elements po na nandun po and yung kanya na po mga percentage po.
So, let's proceed na po sa non-ferrous metals naman po. So, non-ferrous metals po are divided into copper, aluminum, magnesium, titanium, refractory, superalloys, and noble metals po. So, next slide po. So, what are non-ferrous metal or non-ferrous alloys? Non-ferrous metals are metals that contain absolutely no iron. It does not rust easily when exposed to moisture and is not drawn to magnets. They are primarily composed of elements like aluminum, copper, zinc, nickel, and others, often blended with smaller quantities of various metals to achieve specific desired properties. These alloys are prized for their corrosion resistance, electrical conductivity, and the ability to maintain their structural integrity at high temperatures, making them crucial materials in industries ranging from aerospace to electronics. So, yan nga po yung nabanggit kanina. Then, let's proceed to copper na po. So, copper po, it exhibits exceptional resistance to corrosion in a variety of environments, including seawater, the overall atmosphere, and some industrial chemicals. Copper is a highly versatile metal known for its excellent electrical conductivity, making it essential in electrical wiring and components. Its alloys, such as brass and bronze, offer a wide range of properties including enhanced strength, corrosion resistance, and unique aesthetic qualities. These alloys find extensive use in applications like plumbing fixtures, musical instruments, architectural elements, showcasing the adaptability and enduring appeal of copper-based materials. So, ang examples po ng mga copper or application po ng copper alloys are brass instruments like trumpets, horns, and trombones, tsaka po mga bronze instruments like bells, cymbals, and gongs. Pero there are certain copper alloys po which are utilized in surgical and dental tools, mga jet aircraft landing gear bearings and bushings din po, na meron pong high tensile strength up to 1,400 megapascal. Tapos next po is aluminum. Aluminum alloys po are high electrical and thermal conductivity, comparatively low density, and resistance to corrosion in a number of typical conditions, including ambient atmosphere, are the characteristics of aluminum po. Aluminum alloys are a diverse group of metals made by combining aluminum with various elements like copper, silicon, and magnesium. They exhibit excellent strength-to-weight ratios, corrosion resistance, and are widely used in aerospace, automotive, and construction industries. Aluminum alloys play a crucial role in modern engineering, enabling the creation of lightweight and durable components that contribute to energy-efficient and high-performance applications. So, ang example naman po ng pinagagamitan ng aluminum alloys are chemical vessels, materials po sa aircraft and aerospace, tsaka na rin po sa industries ng ships and automotive. Then next po is magnesium alloys. So, the density of magnesium, which is the lowest of all structural metals at 1.7 grams per cubic centimeter, is its most notable feature. It has a low elastic modulus of 45 gigapascal. The magnesium alloys are lightweight metallic materials composed primarily of magnesium, along with other elements like aluminum and zinc. They are known for their exceptional strength-to-weight ratios, making them crucial in industries where weight reduction is paramount, such as aerospace and automotive. Despite their lightweight nature, magnesium alloys also offer good mechanical properties, corrosion resistance, and are increasingly utilized in applications ranging from electronics to medical devices. So, ang examples naman po ng magnesium alloys are helicopter rotors, aircraft landing wheels, gearbox casings, medical implants, tsaka na rin po yung mga cameras, laptops, and mga phones po natin. Then next po is titanium alloys. Titanium and its alloys are relatively new engineering materials that possess an extraordinary combination of properties. The pure metal has an elastic modulus of 107 gigapascal, a high melting point of 1668 degrees Celsius, and a relatively low density of 4.5 grams per cubic centimeter. Titanium alloys are a group of metallic materials composed predominantly of titanium, often mixed with small amounts of elements like aluminum, vanadium, or nickel. Known for their exceptional strength-to-weight ratio, corrosion resistance, and biocompatibility, titanium alloys find a wide range application in aerospace, medical implants, and high-performance sporting equipment. Their ability to withstand extreme conditions coupled with their lightweight makes them invaluable in industries where durability and performance are paramount. So, ang examples naman po ng titanium alloys are boat parts, airplanes, missiles, and rockets. So, let's proceed po sa refractory metals. So, refractory metals po. Refractory metals are defined as those with extraordinarily high melting temperatures. This category includes tantalum, tungsten, molybdenum, and niobium, with melting points ranging from 2,468 degrees Celsius and 3,410 degrees Celsius for niobium and tungsten respectively. Due to their high melting points, the excellent mechanical properties, refractory metals are crucial in industries such as aerospace, nuclear energy, and high temperature processing applications. Additionally, refractory metals are utilized in the manufacture of incandescent light filaments, furnace elements, and specialized tools for high temperature processing in fields like metallurgy and nuclear energy. Their unique properties make them invaluable in environments where materials must endure harsh thermal and mechanical stresses. So, ang examples po ng refractory metals are, as mentioned po, yung pong mga light filaments, then mga rocket nozzles po, heat shields, and other components that face extreme thermal conditions po. Next po.
And we have here the super alloys. Super alloys have superlative combinations of properties. It is a class of high performance alloys that exhibit superior mechanical, physical, and chemical properties at elevated temperatures. And because of this, they are used in a wide range of applications. Most are used in aircraft turbine components, which must withstand exposure to severely oxidizing environments and high temperatures for reasonable time periods. These materials are classified according to the predominant metals in the alloy, of which there are three groups: iron nickel, nickel, and cobalt. And cobalt. Other alloying elements include the refractory metals, which, as mentioned earlier, the niobium, molybdenum, tungsten, tantalum, chromium, and titanium. And last metal under non-ferrous is the noble metals, or the so-called precious metals. It is a group of 8 elements that have some physical characteristics in common. They are expensive where precious came from and are superior or notable where noble is derived in properties that is characteristically soft, ductile, and oxidation resistant, since it is a metallic element that resists oxidation or corrosion even at high temperatures. The noble metals are which to be seen in the next slide. The noble metals are silver, gold, platinum, palladium, rhodium, ruthenium, iridium, and osmium. And the first three are the most common and makikita mostly sa mga jewelry, the silver, gold, and platinum. Followed by that is the miscellaneous non-ferrous alloys. Miscellaneous non-ferrous alloys are a vital part of modern industry and technology. They are a diverse group of alloys that do not fit neatly into any of the major categories of non-ferrous alloys, such as nickel alloy, lead, tin and their alloys, unalloyed zinc and zirconium and its alloys. These alloys are typically characterized by their unique properties and applications, which may be different from each other and will be discussed later. First, we have nickel alloys. Nickel alloys are alloys of nickel with other elements such as chromium, copper, iron, titanium, and molybdenum. They are highly they are highly resistant to corrosion in many environments, especially those that are basic or the alkaline. Nickel is often coated or plated on some metals that are susceptible to corrosion as a protective measure. Monel, a nickel-based alloy containing approximately 65 weight% nickel and 28 weight% copper, which is the balance of iron, has a very high strength and extremely corrosion resistant. It is used in pumps, valves, and other components that are in contact with acid and petroleum solutions. As already mentioned, nickel is one of the principal alloying elements in stainless steels and one of the major constituents in the superalloys. However, followed by lead and tin are the two of the oldest known metals. They have been used for thousands of years to make a wide variety of products, including jewelry, tableware, and weapons. Both of them are also commonly alloyed together to create a new materials with unique properties, most especially as engineering materials. Lead and tin are mechanically soft and weak, have low melting temperatures, and are quite resistant to many corrosion environments and have recrystallization temperatures below room temperature. Applications for lead and its alloys include X-ray shields and storage batteries, where the primary use of tin is a very thin coating on the side of plain carbon steel cans or the tin cans that are used na makikita nyo for food containers. This coating inhibits chemical reactions between the steel and the food products. Followed by unalloyed zinc. It is a pure zinc metal. It is a bluish white metal with a low melting point. It is a good conductor of electricity and heat, where it is also a very malleable and ductile, making it easy to work with. It is a relatively soft metal having a low melting temperature and a sub-ambient crystallization temperature. Chemically, it is a reactive in a number of common environments and therefore susceptible to corrosion. Galvanized steel is just plain carbon steel that has been coated with a thin zinc layer where the zinc preferentially corrodes and protects the seal. Typical applications of this galvanized steel are familiar, which are the sheet metal, fences, screen, screws, and many more. However, the common applications of zinc alloy includes padlocks, plumbing fixtures, automotive parts or the door handles and grills, and also the office equipment. And lastly, although zirconium is relatively abundant in the Earth's crust, not until quite recent times were commercial refining techniques developed. The zirconium and its alloys are ductile and have other mechanical characteristics that are a that are comparable to those of titanium alloys and the austenitic stainless steels. However, the primary asset of these alloys is their resistance to corrosion in a host of corrosive media, including superheated water. Furthermore, the zirconium is transparent to thermal neutrons so that its alloys have been used as cladding for uranium fuel in water-cooled nuclear reactors. However, in terms of cost, these alloys are often The materials of choice for heat exchangers, reactor vessels, and piping systems for the chemical processing and nuclear industries. And they are also used in incendiary ordnance and in sealing devices for vacuum tubes.
So, good morning po. Let's talk about the fabrication of metals. So, fabrication of metals refers to the process of shaping and transforming metal materials into desired forms and structures. It involves various techniques to create parts and components used in different industries. It encompasses a wide range of processes involved in shaping and transforming metal materials, and this includes selecting the right material based on specific requirements such as strength, durability, and corrosion resistance. Fabrication also involves joining techniques like welding, soldering, and brazing to connect metal parts. Furthermore, it encompasses finishing and coating processes, where surface treatments like painting, plating, or powder coating are applied to improve appearance and provide protection against corrosion. Overall, the fabrication of metals is a critical aspect of modern manufacturing, allowing for the production of diverse metal products and structures. So we also have additional details to consider. We have metal selection, material selection, we have the joining techniques, finishing and coating, and the customization. So I'm going to be the one discussing the forming operations. Next slide. So forming operations. Forming operations are those in which the shape of a metal piece is changed by plastic deformation. These operations involve the application of mechanical forces and energy to change the geometry and properties of the material. So it refers to a set of manufacturing processes in which materials, typically metals, are reshaped and transformed into different forms and functions. So these operations involve the application of mechanical forces and energy, as I said, which changes the geometry and properties of the material. So it is commonly used in various industries, including manufacturing, aerospace, automotive, and construction. These are several types of forming operations, each with its own specific techniques. So we also have additional details, which is the types of forming. It includes forging, rolling, extrusion, and drawing, each suited to particular applications and material requirements. We also have the material properties, which talks about the choice of metal and its properties, such as ductility and temperature, greatly influence the forming process. Advantages and limitations, which talks about different forming operations that has specific advantages and limitations regarding precision, material waste, and cost depending on the application. And industry applications, which forming operations are widely used in industries ranging from automotive and aerospace to construction and electronics, demonstrating their versatility and importance in the manufacturing sector. Some of the most common farming operations include, we have the first one, which is forging. Next slide, please. So forging. Forging is mechanically working or deforming a single piece of a normally hot metal. This may be accomplished by the application of successive blows or by continuous squeezing. So forgings are classified as one, we have the closed die. A force is brought to bear on two or more die halves, having the finishing shape such that the metal is deformed in the cavity between them. And the second one, we have the open die. Two dies having simple geometric shapes. Example is parallel, flat, or semicircular, which are employed normally on large workpieces. So it is a process in which is shaped by applying compressive forces, typically through the use of hammers or presses. It is often done at elevated temperatures to make the material more malleable. Forging can improve the mechanical properties and structural integrity of the metal. So, on the closed die forging, it is also known as impression die forging. It is a metal forging process in which a metal workpiece is placed within a set of dies or tooling. These dies have cavities that define the desired shape of the final forged part. The metal workpiece is subjected to high compressive forces and is forced to fill the die cavities, taking on the shape of the die. So, for additional details, closed die forging offers precision and is known for its ability to create intricate and custom shaped parts. And materials suitable for forging include metals such as steel, aluminum, and titanium. The forging process can improve the material's structural integrity and reduce defects. Forged components often have a fine grained structure, enhancing their mechanical properties. So, on the open die forging, it is also called as free forging, which is a metal forging process which the workpiece is not confined within a closed set of dies. Instead, it is shaped by repeated hammer blows or press operations. The metal is manipulated in a way that resembles blacksmithing techniques, and the final shape is achieved through the skill of the operator and repeated deformation. So, the key points in open die forging is that open die forging provides a high degree of flexibility and adaptability. It is particularly useful for creating large and non-standard shapes or custom forgings. And in the material conservation, it typically results in less precision than closed die forging. Open die forging is known for its ability to conserve material since it does not require pre-cutting of the workpiece. In mechanical properties, while open die forging may not provide the same level of control over material properties as closed die forging, it can still improve the strength and other mechanical properties of the metal. In applications, open die forging is often used in the production of large and non-standard forgings such as shafts, bars, and rings. And in closed die forging, it is used in the production of critical components in various industries such as automotive, aerospace, and oil and gas. Examples of parts include gears, connecting rods, and turbine blades. So on the next slide, we have the diagram of the closed and the open die forging. So on the second one, we have the rolling. Rolling is the most widely used deformation process. Consists of passing a piece of metal between two rolls. A reduction in thickness results from compressive stresses exerted by the rolls. Cold rolling may be used in the production of sheet, strip, and foiled with high quality surface finish. Circular shapes as well as I-beams and railroad rails are fabricated using grooved rolls. So it is a metal forming process in which a metal workpiece is passed between a pair of rollers, resulting in change in thickness, shape, and surface finish. It can be performed either at elevated temperatures, known as hot rolling, or at a near room temperature, known as the cold rolling. Hot rolling is commonly used in steel production, where large slabs or billets are shaped into various products like plates, sheets, and structural sections. Cold rolling, on the other hand, is often employed in the production of precision components such as automotive body panels, foil, and electrical wires. So, in the key points, we have the hot rolling. It is the where the metal is heated to a high temperature, making it more malleable. This allows for easier deformation and shaping. It is commonly used in the production of steel, where large slabs or billets are rolled into various products like plates, sheets, and structural sections. In cold rolling, it is performed at near room temperature and is typically used to improve the surface finish and dimensional accuracy of the metal. It is widely used in the production of precision components such as automotive body panels, foil, and electrical wires. So the advantages is that it has improved surface finish. Cold rolling in particular results in a smoother and more polished surface. And dimensional accuracy, rolling helps achieve precise dimensions in metal products. So in terms of applications, rolling is essential in industries like steel production, where it's used to create sheets, bars, and structural sections. It is also used in the production of automotive body panels, pipes, and tubes. So on the next slide, we have the diagram for the rolling. So on the third one, we have the extrusion. So for extrusion, a bar of metal is forced through a die orifice by a compressive force that is applied to a ram. The extruded piece that emerges has the desired shape and a reduced cross-sectional area. Extrusion products includes rods and tubing that have rather complicated cross-sectional geometries. Seamless tubing may also be extruded. So it is a metal forming process that involves pushing or forcing a material, often heated, through a die to create a specific shape or cross-section. This method is known for its ability to produce consistent, complex profiles with precision. making it highly adaptable to various industries. Hot extrusion, achieved through the heating of the material, is commonly used for materials like aluminum and copper. In contrast, cold extrusion performed at or near room temperature is suitable or is suited for materials that are not as malleable when heated. Industries such as construction, automotive, and electronics utilize extrusion to manufacture an array of products, including aluminum profiles, pipes, wires, and structural components. So, in hot extrusion, the material is heated to a high temperature, which makes it easier to deform or shape. This method is commonly used for materials like aluminum, copper, and certain plastics. Cold extrusion is performed at near room temperature and is used for materials that are not as malleable when heated. It is often used for producing precision parts with fine details. So the advantages is in terms of design flexibility, extrusion provides great design flexibility for creating complex shapes and profiles. Cost effectiveness, it's a cost effective method for producing consistent high quality parts. In applications, it is used in various industries including construction, automotive, and electronics. It is employed to manufacture products like aluminum profiles, pipes, wires, and various other structural components. So in the next slide, we have the diagram for the extrusion. So additional details, extrusion is a continuous process ensuring uniformity in the cross-sectional shape of the product. The process offers design flexibility and the ability to create intricate and customized profiles. So materials commonly used extruded included metals. We have aluminum, steel, brass, plastics, and composites. Extruded products are often lightweight and have high strength to weight ratios. Extrusion dies can be designed for specific shapes, from simple rods to complex architectural profiles. So on the fourth one, we have the drawing. So drawing is the pulling of a metal piece through a die having a tapered bore by means of a tensile force that is applied on the exit side. A reduction in cross-section results, with a corresponding increase in length. Rod, wire, and tubing products are commonly fabricated in this way. So it is a metal forming process in which a metal rod, wire, or tube is pulled through a die to reduce its diameter or lengthen it. This process is vital for industries that require precise control over the dimensions of their products, such as electrical wires, cables, and precision components. Drawing not only reduces the diameter, but also enhances the mechanical properties of the material, making it stronger and more ductile. The process can be performed on a variety of materials, including metals and polymers. So we have wire drawing versus tube drawing. Wire drawing is used to reduce the diameter of wires, often used in the production of electrical wires, cables, and small diameter components. On the other hand, we have tube drawing, which is employed to reduce the diameter and lengthen tubes or pipes, often used in the manufacturing of medical tubing and other precision components. So the advantages of drawing, it improves mechanical properties. Drawing can enhance the mechanical properties of the drawn metal, making it stronger and more ductile. In precision, the process allows for precise control over the diameter and length of the drawn material. In applications, wire drawing is used in in the production of wires, cables, and springs. Tube drawing is employed in manufacturing medical tubing, automotive components, and various precision parts. So these metal forming operations that I discussed, which are four, are essential in the manufacturing industry, enabling the production of a wide range of products and components with different shapes, sizes, and material properties. So on the next one, we have the diagram for drawing. So wire drawing is commonly used in the production of electrical wires, cables, and small diameter components. Tube drawing is used to reduce the diameter and lengthen tubes or pipes, making it valuable in the production of wires. Wires are essential tools for this process, and they are designed to meet specific dimensional requirements. The process is typically performed at room temperature, preventing heat-related issues that can arise in other metalworking methods. Drawing offers high precision, enabling the production of components with tightly controlled dimensions.
Good morning po. So let's proceed to casting. So what is casting? Casting is a manufacturing process in which molten metal is poured into a mold. Solidification. It takes on the mold shape with some shrinkage. This method is used when the finished shape is so large or complicated that any other method would be impractical. The metal alloy has low ductility, making hot or cold working difficult. Also, casting is the most cost-effective option compared to the manufacturing processes. Next po. Sand casting. Sand casting is a common method where ordinary sand is used as the mold material. It involves creating a two-piece mold by packing sand around a pattern that matches the desired casting shape. A gating system is typically added to the mold to facilitate the flow of molten metal into the cavity and reduce internal defects. So sa sand casting po ay gumagamit po dito ng sand desired shape para ma-mold yung molten metal. Next po. Next is die casting. Die casting is a manufacturing process where liquid metal is injected into a mold with high pressure and velocity, and the pressure is maintained as the metal solidifies. This method utilizes a two-piece permanent steel mold that forms the desired shape when clamped together. After solidification, the mold is opened and the cast piece is removed. Die casting is a suitable for relative small components and alloys with low melting temperatures such as zinc, aluminum, and magnesium. In the next stage po, makikita po natin sa picture yung process kung paano yung die casting. Next po. Yan. Dito po sa picture ay ipupur po muna natin yung molten metal dun sa die casting machine. Then, dun sa left side po, ano dun yung plunger. Yung plunger po yung magpe-pressure dun sa molten metal papunta dun sa ejector die and injector pins para po masolidify yung metal at mabuo yung final object natin. Next po. Investment casting. It is also called lost wax casting. Involves creating a pattern from wax or low melting plastic. A fluid slurry, typically made with plaster of Paris, is poured around the pattern to create a solid mold. The mold is then heated, causing the pattern to melt and burn out, leaving a mold cavity with the desired shape. This method is used for application that demand high dimensional accuracy, the reproduction of fine details and superb finish, such as in jewelry, dental crowns, inlays, as well as for casting blades in gas turbines and jet engine impellers. So, sa next slide po, makikita po ulit natin yung process kung paano ginagamit yung investment casting. So, sa 1 and 2 po, imomold muna yung wax na sa gusto nating shape para po para dun po, pag pinur natin yung metal mamaya, ay maging ganong shape yung final object. Then sa 3 naman po, ay i-assemble natin yung mga nagawa nating wax pattern sa pattern 3. Sa 4 naman po ay slurry coating. Ilulublob po natin yung pattern 3 sa ceramic slurry para para tumigas yung ating yung ating mold. Then sa 5 naman po is stucco coating ay para po mas lalong patigasin pa yung na mas lalong patigasin na medyo malutong para pag nag-solidify na yung molten metal natin ay madali siyang basagin. So sa 6 naman po ay yun na po yung completed mold. Then sa 7 ay um, lalagyan po natin ng heat yung pattern 3 para yung wax na pattern natin ay matunaw tapos tumulo na. Then sa 8 naman po ay lalagyan na natin ng molten metal yung nabuo nating mold. Then sa 9 ay pag tumigas na ay babasagin na natin yung stucco coating. And then sa 10 ay makikita na natin yung final object. Next po. Lost foam coasting uses polystyrene foam patterns encased in sand molds. When molten metal is poured in, it vaporizes the foam, leaving the metal to solidify in the desired shape. It's commonly used for cast iron and aluminum alloy parts, like engine blocks and crankshafts. Next po. So ito naman po yung process ng lost foam coasting. Sa lost foam coasting, ang ginagamit natin is polystyrene. Ilalagay mo siya sa isang box, tapos ilalagay mo sa gitna yung polystyrene, then yung palibot ng polystyrene, pupunuin mo siya ng sand. Then ilalagay mo na doon sa polystyrene yung molten metal. Tapos yung polystyrene, pag nilagyan siya ng molten metal, mag-evaporate siya kasi yun yung kanyang characteristic. Next po. Continuous casting. In metal extraction processes, molten metals are solidified in large ingot molds, followed by hot rolling to create flat sheets or slabs. These flat shapes are more convenient for further metal forming processes. Continuous casting is an automated and efficient method where molten metal is cast into a continuous strand with a desired cross-sectional shape. Next po. So ito naman po yung process ng continuous casting. Sa continuous casting po kasi parang ito na po yung pinakamadaling paraan para mapadami yung product. Madaming magawa yung product. Inilalagay po muna yung molten metal sa ladle, then pupunta siya sa tundish, magmo-mold, then yan na po yung process. Then mabubuo na po agad yung kung ano man yung ginawa niyong shape. Next na po.
So we're now moving to miscellaneous techniques po. Miscellaneous techniques include methods and practices that do not fall into certain categories but may be used in a range of settings to attain specific goals or address difficulties. These strategies are adaptable and may be applied in a variety of professions and disciplines. So miscellaneous techniques encompass a diverse array of methods and practices that don't neatly fall into predefined categories or specific disciplines. They are categorized by their adaptability and can be applied in various contexts to address specific challenges, optimize processes, or facilitate problem solving. These techniques are often versatile and not limited to any particular industry or field, making them valuable tools for individuals and organizations seeking creative solutions or improvements. They can range from brainstorming and mind mapping for generating ideas and organizing thoughts to advanced problem-solving methods like root cause analysis and Six Sigma, used in quality control and process optimization. Whether it's decision trees in data analysis, the use of Pareto principle for efficient resources allocation, or practices like time management techniques to enhance personal productivity, miscellaneous techniques are versatile and adaptable, making them essentials for tracking a wide range of problems and achieving diverse goals. Next slide po. So, powder metallurgy. Powder metallurgy is a manufacturing process that creates a metal parts by compacting and heating fine metal powders to form solid components with reduced waste and improved properties. Uh, it is a manufacturing process that involves producing metal parts and components by compacting finely powdered metal materials into a desired shape and then sintering or heating without melting them to bond the particles and create a solid dense structure. This process allows for the production and integrate and nearly shape parts often with enhanced properties and reduced waste. Powder metallurgy is utilized in various industries including automotive, aerospace, and electronics to manufacture items like gears, bearings, and cutting tools. Next slide. So the next one is welding. Welding is the process of joining metals by melting them at the joint and fusing them together as they cool, creating a strong connection. It's widely used in construction, manufacturing, and various industries. Welding is a fabrication process that involves joining two or more pieces of metal or thermoplastic material together by bending them at the joint and fusing them into a single piece when they cool. This process is commonly used in various industries for building and repairing structures, vehicles, machinery, and many other products. Welding rods or wire, while others rely on the base materials themselves to create a strong bond. Welding plays a crucial role in construction, manufacturing, and many other fields, as it allows for the creation of durable and structurally sound connections between materials. So next one po. So we're now moving to heat treatment. Heat, tre- Heat treatment is commonly linked to be enhancing material strength, but it's versatile. It can also improve machinability, formability, and restore ductility after working. This process not only aids other manufacturing methods but can also enhance product performance by strengthening or enhancing desired attributes. So, it is a manufacturing process that involves heating and cooling materials, typically metal, in a controlled manner to alter their properties, such as hardness, toughness, ductility, or other mechanical physical characteristics. The primary purpose of heat treatment is to enhance the material's performance and suitability for specific applications. So, in the heat treatment, there are processes and types. So, the first one is annealing, hardening, and the normalizing that will be discussed in the next slides. Next po. So, annealing is a heat treatment process that involves exposing a material to a high temperature for an extended period and then gradually cooling it. This process is used to relieve stresses, enhance softness, ductility, toughness, and create a desired microstructure. So, annealing is a heat treatment process used to alter the properties of material, typically metal, by heating it to a specific temperature and then slowly cooling it. The primary objective of annealing here is to relieve internal stresses, increase softness, enhance ductility, and create a specific microstructure within the material. The annealing process typically involves the following steps. The first one is heating. The material is heated to a specific temperature which often above the upper critical temperature. This temperature varies depending on the type of material and composition. The next one is the soaking. The material is held at the specific temperature for a predetermined period to ensure uniformity of the temperature throughout the material. And the last one is the cooling. After the soaking period, the material is gradually cooled at a controlled rate. The slow cooling helps in achieving the desired changes in material structure and properties. So next slide po. So the next one is the normalizing. It is a heat treatment process that refines green structure and achieves more uniform size distribution. It involves heating the material to at least 550 degrees Celsius or 1000 degree Fahrenheit above the upper critical temperature but doesn't provide the same uniform material properties as annealing. So, normalizing po is yun, is a heat treatment process used to refine and grain structure of a material. So, basically po sa mga metal din to at na-achieve po natin ang more uniform size distribution. Unlike po sa annealing which is involves slow cooling, normalizing involves cooling the material in still air po. The primary objectives of normalizing are to improve machinability, formability, and attain more consistent microstructure within the material. So the normalizing process generally consists of the following steps. So meron po silang pagkakaparehas ng annealing, which is the first step po is heating. The material is heated to a temperature typically above the upper critical temperature, but not as high as in some other heat treatment processes like hardening. Soaking. The material is held at the specific temperature for a sufficient duration to ensure that reaches a uniform temperature throughout the entire structure. And the last one is air cooling. Instead, instead of a controlled and slow cooling process, normalizing involves cooling the material by allowing it to cool naturally in still air. So may mga benefits po ang normalizing heat treatment. So ito po 'yan. Improve machinability. Normalizing enhances the material's machinability, making it easier to cut, shape, and machine. And the next one is better formability. The material becomes more ductile, making it easier to deform, bend, or shape. And the next one is grain refinement. Normalizing helps to refine the grain structure within the material, resulting in a more uniform and consistent microstructure. And normalizing is commonly used in manufacturing process where the mechanical properties of the material need to be optimized, such as the production of steel components for various industries, including automotive, construction, and machinery. The specific normalizing temperature and cooling rate depend on the material type and intended application. Next slide po. So the next one is hardening. It is the process of increasing the hardness of a metal by heating it to a specific temperature and rapidly cooling it in a medium like water, brine, oil, or air. It is a heat treatment process used to increase the hardness and strength of a material, typically metal po. This process involves heating the material to a specific temperature and then rapidly cooling it by quenching it in a liquid medium, such as water, oil, brine, or even air. The rapid cooling known as quenching is a key type in hardening and is what distinguishes it from other heat treatment processes like annealing or normalizing. The hardening process generally consists of the following steps. The first one is heating. The material is heated to a temperature above its critical temperature but below its melting point. This temperature varies depending on the type of material and its composition. The second one is the soaking. The material is held at the specified temperature for a sufficient duration to ensure that it reaches a uniform temperature throughout the entire structure. The last one is quenching. After the soaking period, the material is quickly cooled in a immersing it in a quenching medium. This rapid cooling freezes the material's microstructures and results in a increased hardness. So ang hardening po ay nagsaserve ng following processes like increase hardness po. Kasi nga po hardening po ito. So hardening significantly increases the material's hardness, making it more wear resistant and suitable for applications where strength and durability are critical. So the next one is enhance strength. The rapid cooling during the quenching also leads to improved strength properties in the material. So hardening is commonly used in the manufacturing of various tools, machine parts, and components were resistant to wear, abrasion, and fatigue is essential. The specific hardening temperature, quenching medium, and processes parameters depend on the material and the desired properties for a particular application. Next slide po.
For the aging or the precipitation hardening, it is a heat treatment method mostly used to increase the yield strength of malleable metals. The process produces uniformly dispersed particles within a metal's grain structures, which brings about changes in properties. So, what are the processes of aging or precipitation hardening? First step is to the solution treatment. The alloy is heated to a high temperature above the solubose temperature of the solute. This causes the solute atoms to dissolve into the solvent, forming a solid solution. Next step is the quenching. The alloy is then rapidly cooled. This prevents the solute atoms from participating out of the solid solution and traps them in a saturated state. And And lastly, the aging. The alloy is then held at a lower temperature for a specific period of time. This allows the solute atoms to diffuse and form fine precipitates within the grain structure of the alloy. Aging is commonly used to strengthen aluminum, magnesium, nickel, and titanium alloys. Next slide. Next is the relieving, especially common for boiler parts, air bottles, accumulators, etc. This method takes the metals to a temperature just below its lower critical border. The cooling process is slow and therefore uniform. This is done to relieve stresses that have built up in the parts due to earlier processes such as forming, machining, rolling, or straightening. So how does it works? So relieving works by allowing the atoms in the material to move and relax, which reduces the amount of stress relief that is achieved. Depends on the temperature and the heat treatment. And stress relieving is commonly used for steel, cast iron, and aluminum alloys. Next type is the tempering. So, tempering carried out by preheating previously quenched or normalized steel to a temperature below lower critical temperature, often from 205 degrees Celsius to 595 degrees Celsius, holding and then cooling to obtain the desired mechanical properties. So what are the processes involved in tempering? So first is the heating. The metal is heated to a temperature below the recrystallization temperature of the material. Next is soaking. The metal is held at a tempering temperature for a specific period of time. And lastly is cooling. The metal is cooled at a controlled rate. Next is the case hardening. For case hardening or surface hardening is the process of hardening the surface of steel while leaving the interior unchanged. It improves the wear resistance of machine parts without affecting the top interior of the parts. So sa case hardening, meron ditong three types which is the carburizing, cyaniding, and trading. For carburizing, the process of increasing the carbon content of the surface of steel. It is a heat treatment process in which iron or steel is heated in the presence of another material in the range of 900 to 950 degrees Celsius, which liberates carbon as it decomposes. Or simply saying, carburizing is the method that adds carbon to the surface of the part by heating it in an atmosphere that is rich in carbon. Next, next slide is the cyaniding. It is a process of producing hard surfaces by immersing low carbon steel in cyanide, both maintained at 800 degrees Celsius to 850 degrees Celsius. The parts are then quenched in water or soil or oil. This process helps to maintain bright finish of the parts. So dito, um, next slide is the nitriding, which is the process of diffusing the nitrogen into the surface of steel. The process is carried out by heating of steel in the presence of dissociated ammonia at a temperature of 400 degrees Celsius to 500 degrees Celsius. The diffused nitrogen combines with iron and certain alloying elements present in steel and form respective nitrides. So for simply saying, nitriding is a method that adds nitrogen to the surface of the part by heating it in an atmosphere that is rich in nitrogen. For addition is the induction hardening. This method uses an electromagnetic field that heat the surface of the part to a high temperature. Overall, case hardening is commonly used for gears, bearings, and shafts.
Yun, and that's all po for non-ferrous, ferrous and non-ferrous metals po.
Okay, so thank you po sa group ng metals. Yan. Meron po ba kayong tanong about po sa metals? So, halos yung mga naandun po sa atin pong module is na-discuss naman po dito. Any question po about po sa metals? Meron kayong tanong? May gusto ba kayo dyan na mas i-discuss pa po ng ayos? Pwede niyo po akong i-message ano po para ma-discuss po natin sa kapag ako na po yung ulit po na magpe-present. Okay, so nandito na po ang group ng ceramics. Makikitaas naman po ng kamay ng mga ceramics. 1, 2, 3, 4, 7 kayo. Okay. Okay. So if ready na po kayo, so makiki-present na lang po ulit. Okay po.
So, good morning everyone, and we are the group 2, and our topic is about ceramics. Next slide. So, we will be discussing about what is ceramics, structure and properties of ceramics, mechanical properties, typical properties, classification of ceramics, and microelectromechanical system or yung MEMS, fabrication and processing of ceramic, and fabrication and processing of clay products. Lahat ng yan ay madidiscuss ng reporter ng Group 2. So, next slide. So, after we discuss all those topics, you can differentiate the types of ceramic materials, determine the different application and process of ceramics. And lastly, you can explain the process involved in processing and fabrication of ceramic materials. So, let's start the discussion. So, what is ceramics? So, from the definition, the term ceramic comes from the Greek word keramikos, which mean burn stuff. Or yung nasa module 1 natin na yung keramikos is ano siya, yung of pottery or for pottery. So, nag-indicate lang to ng the properties of this material are normally achieved through a high temperature heat treatment process. So, ang ceramics daw ay nagagawa through a high temperature treatment process. O kailangan niya ng mas mataas na temperature para maging mas matibay yung pagbubuo mo ng ceramics. So, ang ceramics then are non-metallic, inorganic material typically made from clay and other natural substances that are hardened through heating at high temperature. So yun nga. They are known for their hardness, strength, and ability to withstand the high temperature, making them suitable for a wide range of application, including pottery, tiles, and advanced material used in engineering and technology. So next slide. So, yan, meron ang ceramics daw ay may tatlong types. Yun yung earthenware, stoneware, at porcelain. Ano yung ang earthenware daw is a clay fired at relatively low temperature or between 1,000 to 1,500 degrees. Ang result nito is hardened but brittle material which is slightly porous. So, ang stoneware naman ay pinainitan siya ng higher temperature na meron siyang 1,200 degrees. Ang porcelain naman is pinainitan ito or inaano siya sa high temperature approximately 1,200 to 1,400 degrees. So, anong pagkakaiba ng tatlong yan? Yun lang, yun sa nung temperature at which the clay is pared and resulting strength, water resistant and durability of the finished product. Sa lang sila nagkakaiba-iba sa nung high temperature na yon. So, next slide po.
Hello. So let us first understand the structures and properties of ceramics. Covalent bonding and ceramic crystal structure. Next. The first one is ceramic bonding. This refers to the way atoms and molecules in ceramic materials stick together. So sa ceramic bonding po, ang una is yung ionic bonding. One of the atoms transfers electrons to another atom, thus becoming positively charged, whereas the nonmetal becomes negatively charged. The two ions having opposite charges attract each other with a strong electrostatic force. So in ceramic bonding, it's how the particles hold onto each other to form a solid structure. In simple terms, ceramic bonding is like the glue that holds ceramic materials like pottery or tiles together. Kagaya po ng sinabi kanina. So for ionic bonding, it is when an atom gives or takes an electron to make them stable. One example of this is the table salt or yung sodium chloride. Sodium has one excess electron whereas the chloride needs one more electron to make it stable. The sodium will give an extra electron to chloride to make them both stable. So kung makikita nyo po sa picture, yung sodium may extra siya na electron, yung mga X. Tapos yung sa chloride, yung mga dots, may excess siya na electron. Ibibigay lang po ni sodium yung extra niya na electron sa chloride para maging stable sila parehas. After that, the sodium will become positively charged and the chloride will become negatively charged. And since opposite attract, magdidikit po sila causing ionic bonding. Next po. Next is covalent bonding. This occurs between two nonmetals, in other words, two atoms that have similar electronegativity. This involves the sharing of electron pairs between the two atoms. Although both types of bonds occur between atoms in ceramic materials, in most of them, particularly the oxides, the ionic bond is predominant. This is just like the ionic bonding, but in this bonding, the two nonmetals who lack an electron will share electron to make each other stable. An example of this is chlorine, yung Cl2. The chloride, when combined with another chloride, in this case, both lack one electron. So they will share the electron, thereby making them stable. It is also said that, excuse me, though both bonds are predominant, So for the ceramic crystal structure naman, we have AX-type crystal structure. These have equal numbers of anions and cations. The AX crystal structure is a simple way to describe the arrangement of atoms or ions in certain types of crystal structures. In this system, A represents the central or cation, and the letter X represents the surrounding anions, which is the negatively charged ions. And they are bonded to the central cation. So in simple terms, you can think of it as the A atom or ion at the center and the X atoms or ions surrounding it in a specific pattern. The arrangement of X ions around the A ion can vary, and it's a way to calculate the crystal structure. For example, in sodium chloride or yung table salt, is a sodium ion and the X is a chloride ion. And they are arranged in a repeating pattern in a crystal lattice. So meron po tayong tatlong example ng AX-type crystal structure. Ito yung rock salt structure, cesium chloride structure, or zinc blended structure. Next po. The first one is rock salt structure. Unit cells generated from FCC cation and anion arrangement. Its coordination number for cation and anion is 6. Cation anion radius ratio is between approximately 0.414 and 0.732. The rock salt structure is a specific type of crystal structure often found in compounds like table salt. In a rock salt structure, the atoms or ions are arranged in a repeating pattern that looks like a stack of cubes. So in simple terms, the rock salt structure is like building a stack of cubes where each cube is made up of one type of atom at the center, and another type of atom at the corners. Excuse. This arrangement is characteristics of many common ionic compounds and gives them their solid crystalline appearance. So ayan po yung nasa picture, yung example. Nasa center po yung chloride, tapos yung sodium nasa sides. Next po. The cesium chloride structure. Its coordination number is equal to 8 for both ions. This looks like BCC but is not because it is composed of different ions. The anions are located at each of the corners of a cube, whereas the cube center is a single cation. This is a specific type of crystal structure commonly found in compounds like cesium chloride, or the CSCl. In this structure, the atoms are arranged in a straightforward manner. In simple terms, the cesium chloride structure is like stacking cubes in a checkerboard pattern, with cesium atoms at the corner and chloride atoms at the center. This arrangement is common in certain types of ionic compounds, giving them their distinctive crystal structure. And po example sa cesium chloride structure. Next po. The zinc blended structure. Its coordination number is equal to 4, and all ions are tetrahedrally coordinated. All corners and faces positions with S atoms and Zn atoms, or the zinc and the sulfur, fill tetrahedral spaces and vice versa. This is also known as sphalerite structure after the mineralogical term for zinc sulfide, or yung ZNS. The zinc blended structure is a specific type of crystal structure found in compounds like zinc sulfide. It is called zinc blende because it was first discovered in a mineral containing zinc and looked like a shiny angular crystal. So imagine stacking two interpenetrating or interlocking face-centered cubic, yung FCC lattice. And each lattice is made up of two different types of atoms or ions. So sa zinc blended structure, one set of atoms represent one element. For this example is the zinc. And the other set represent another element, like the sulfur. Ayan po, yung nasa picture. Next po. The next type is the AMXP type crystal structure. Cation X and anion A have different charges. M and or P is not equal to 1. So to maintain a neutral structure, there is an even number of cations and anions. Coordination number is equal to 8 and similar to cesium chloride structure, but only half the center spaces are filled. An AMXP type crystal structure is a way to describe the arrangement of atoms in certain types of compounds, typically in the context of complex minerals and compounds in chemistry. In this notation, AM represents the metal cations, which is the positively charged ions, and the XP represents the nonmetal or the anion atoms, which is the negatively charged ions in the compound. And the M and P are usually the whole numbers that indicate the ratio of these atoms in the chemical formula. So for this example, the calcium fluoride CaF2. Ayan po yung structure niya. Next po. The AMBNXP types crystal structure. Ceramic with more than one type of cation, represented by A and B. Their chemical formula may be designated as AMBNXP. An example of this is barium titanate, which is a perovskite crystal structure. So an AMBNXP type crystal structure is a way to describe the arrangement of atoms in certain types of compounds, typically in the context of complex minerals and compounds in chemistry. So AM represent one type of metal cations, which is the positively charged ions, and BN represents another type of metal cations. The XP represents the nonmetal or anion atoms, which is the negatively charged ions in the compound, and M, letter N, and letter P are usually whole numbers that indicate the ratio of these different types of atoms in the chemical formula. To simplify, think of it like a recipe for a compound. You have different kinds of metal atoms, which is the AM and BN, along with nonmetals, which is the XP. And the numbers M, N, and P tell you how many of each are mixed together to create the compound structure. Next. So for the summary of some common ceramic crystal structure. Sa rock salt, ang type niya is AX. An ion packing is FCC. Cation and anion are both 6. And example nito yung table salt tsaka ayan, MgO, FeO. For cesium chloride, ang structure type niya is AX. This is a simple cubic with 8 cation and anion. Tapos zinc blende, which is the sphalerite, is an AX structure type, also an FCC. Both cation and anion is 4. For fluorite is AX2. So for every A, there is 2x. Ganun lang po yan. For an ion packing, simple cubic, sa cation is 8 and anion is 4. Perovskite is ABX3. So for every 1A, there is 3x. For anion packing, FCC, for cation, meron siyang 12A na 6B. Tapos anion is 6. For spinal, AB2X4. So for every 1A, there is 2B and 4X. Ang anion packing naman is 4cc. For cation, 4A and 6 na B. For anion is 4. Yun lang po.
So, mechanical properties of ceramics. The properties of ceramics, however, also depend on their microstructure. Ceramics are by definition natural or synthetic inorganic non-metallic polycrystalline materials, sometimes even monocrystalline materials such as diamond and sapphire, are erroneously included under the term ceramics. Polycrystalline materials are formed by multiple crystal grains joined together during the production process, where monocrystalline material are grown as one three-dimensional crystal. Fabrication process of polycrystalline material are relatively inexpensive when compared to single crystalline. And another info, ceramics are one of the material known for their brittle nature and excellent hardness. Their mechanical properties typically include high compressive strength, low tensile strength, high stiffness, and excellent resistance to wear and corrosion. This property makes ceramics suitable for application for cutting, tools, ball bearings, and insulating materials.
So ano, dako na tayo sa typical properties of ceramics. So isa-isahin natin 'tong mga nakalista dito. So sabi sa definition kanina na ang ceramics ay made up of either metal or non-metal compounds na na-shape. Tapos naha-harden siya by heating to high temperatures. So yung paggamit ng high temperature ay ina-allow niya yung mga tiny grains ng individual ceramic components na magsama-sama or mag-fuse yun, mag-fuse together. So kaya mataas talaga yung ceramics, yung hardness niya. Kaya yun yung unang properties ng ceramics. Meron siyang high hardness. So ang pangalawa natin na isa pang property ng ceramics ay high elastic modulus. Ano ba 'pag sinabing high elastic modulus or high modulus of elasticity? So, ibig sabihin nito ay sa pagtaas ng elastic modulus ay sa pagtibay ng ating material. Since nagtataglay nga siya ng high elastic modulus na property, so hindi siya basta-basta masisira or made-deform. So, yun yung isang magandang property ng ceramics. So, pangatlo, nagtataglay ito ng low ductility. 'Di ba sa meron tayong tatlong chemical bonding, yung ionic, covalent, and metallic bonding. Sa ceramic bonding, based sa definition niya, ang dalawang common chemical bonds para sa ceramic materials ay ionic and covalent. Yung bonding of atoms kasi sa dalawang yun ay stronger than metallic. Kaya masasabi natin na ang ceramics ay brittle at hindi siya ductile. Kaya ang ceramics ay nagtataglay ng low ductility. So, isa pang property nito ay high dimensional stability. Dahil nga nagtataglay ang ceramics ng high hardness, so kayang i-maintain ng ceramics ang kanyang original shape, makompress man siya or ma-stretch. Kumbaga ay nare-resist niya yung change in dimension niya kahit ito ay kino-compress or ini-stretch. Panglimang properties ng ceramics ay meron din siyang good wear resistance. Ano ba ang wear resistance? Ang wear resistance ay ito. Ito yung material's ability to resist material lost by some mechanical action. Ang ceramics kasi ay suited talaga siya na ma-resist ang ganong mechanism dahil nga gaya ng sabi ko kanina, yung chemical bonds na nagho-hold sa ceramics ay extremely hard tsaka strong. So next natin ay high resistance din siya sa corrosion. Ito naman yung ability ng material na ma-withstand yung corrosion damage caused by oxidation or other chemical reactions. Kaya mataas ang corrosion resistance ng ceramics kasi yung chemical bonds niya kasi ay ng ceramics ay oxides na-oxidize na. Kaya naman unaffected na sila tuwing may oxidation process. Hindi na sila nagkakaroon ng corrosion damage. Ang pampito natin ay nagtataglay din ito ng high weather resistance. Since ang chemical bonds nga ng ceramics ay hard and strong, kaya din itong i-withstand ang high or low temperature. So next po. Ang sunod na property ng ceramics ay meron itong high melting point. Dahil nga sa strong na covalent or ionic bonds na nagho-hold sa structure nito, bago matunaw ang ceramics ay kailangan talaga ng napakataas na temperature para matunaw. So, karamihan ng ceramics gano'n. Ang melting point ng ceramics ay above 2,000 degrees Celsius. So, gano'n yung required na temperature bago matunaw ang isang ceramics. Sunod ay high working temperature. Since napakataas nga ng melting point ng ceramics, kaya din ito i-withstand ang mataas na temperature. Dahil nga ceramics ay ideal material siya para sa mga high temperature applications. Sunod naman ay ang ceramics ay meron itong low thermal expansion at low to medium thermal conductivity. Dahil nga strongly bonded ang chemicals ng ceramics, contrast naman dito yung level ng conduction at expansion ng heat. Hindi siya basta-basta kumakalat, hindi siya basta-basta nakakapag-conduct ng heat. The next one natin ay ang ceramics ay isang good electrical insulation. So dito, 'di ba, para mag-flow ang electricity, kailangan gumagalaw ang mga electrons or kailangan may loose na electrons para makapag-flow ang electricity. Kaso ang ceramics ay isang example kasi siya ng insulator. At ang insulator ay walang loose na electron, so hindi magfo-flow ang electricity. Kaya masasabi natin na good electrical insulator ang mga ceramics. Ang ceramics naman ay nagtataglay din siya ng low to medium tensile strength. Ibig sabihin, low din ang kanyang fracture toughness. 'Di ba 'pag sinabing tensile strength, ito yung amount ng load or stress na kayang i-handle ng material hanggang siya ay ma-stretch at masira. So, ibig sabihin nito, mababang tensile strength lang ang required para masira ang ceramics. At ang last naman natin, na typical property ng ceramics ay meron siyang high compressive strength. Ang compressive strength kasi, siya naman yung kabalik para siyang tara ng tensile strength. Kung ang tensile ay nagre-resist ng tension, ang compressive naman nagre-resist ng compression. Kung ang tensile ay pa-stretch, ang compressive naman ay kino-compress na yung material hanggang sa mag-break ito. Dahil high compressive strength ang ceramics, so required din nito ng high compression force para masira. So, yun lang para sa typical properties of ceramics. So, dako na tayo sa classification of ceramics.
So, hello. Ngayon, tatakal ko ang classification of ceramics. Meron tong pito. Ito yung mga glasses, clay product, refractures, abrasives, cement, carbons, and advanced ceramics. Next slide. So, ang unang classification ng ceramics ay itong glasses. So, the glasses are a familiar group of ceramics, containers, lenses, and fiberglass represents typical applications. Possibly the two prime assets of this material are their optical transparency and the relative ease with which they may be fabricated. Glass ceramic materials have been designed to have the following characteristics: relatively high mechanical strength, low coefficients of thermal expansion to avoid thermal shock, good high temperature capabilities, good dielectric properties for electronic packaging applications, and good biological compatibility. Glass ceramics are manufactured commercially under the trade names of Pisoxera, Corningware, Cedar, and Vision. So dito sa glasses is tulad nga ng sinabi sa mga ceramics dati is kailangan siya ng high temperature para maano. 'Di ba ang glasses alam naman natin is gawa siya sa sand. Kung yung napanood kung anime na Doctor Stone, yung sand is nagagawa siyang glasses a through sa furnace na may taas na heat. So, ang isa pang maganda sa glasses nga tulad dito is yung transparent siya. Ibig sabihin, nakikita natin yung nasa loob. Tapos, sabi din dito na ito yung thermoshock na kita naman natin ngayon na yung mga bumbilya natin is ina-isolate siya sa mga glasses. Kaya, para maiwasan yung mga sunog, syempre, common sense naman na kapag yung nilagay sa mga kahoy, baka masunog na yung kahoy. Kaya ito yung maganda sa mga glasses. Next slide. Ito naman, sa clay products. One of the most widely used ceramic raw materials is clay. This inexpensive ingredient, found naturally in great abundance often is used as mine without any upgrading of quality. Another reason for its popularity lies in the ease with which clay products may be formed when mixed in the proper proportions. Clay and water form a plastic mass that is very amenable to shaping. Most clay-based products fall within two broad classifications: the structural clay products and whitewares. Structural clay products include building bricks, tiles, and sewer pipes application in which structural integrity is important. Whiteware ceramics became white after high temperature firing. So, dito naman sa clay is, ang clay naman is, nakikita naman natin kadalasan sa mga pottery. So, ang kagandahan kasi sa clay, kapag minekos-mekos siya ng ating mga insan, is napakadali niyang i-form. Kumbaga, kapag nagkamali ng mekos-mekos ang ating insan sa clay, pwede natin siyang dagdagan lang at yung pagkakamali natin nagawa is pwede natin siya may correct sa clay products. Unlike sa mga glass is napakahirap niyang ano pa nagkamali tayo ng pagkaano doon. Tapos ang sinabi nito sa clay na pag kaya kung paano siya patigasin is kailangan natin siya ibilad sa araw para maano yung kanyang durability. Next. Sunod naman natin is refractories. The salient properties of these materials include the capacity to withstand high temperature without melting or decomposing and the capacity to remain underactive and inert when exposed to severe environments. In addition, the ability to provide thermal insulation is often an important consideration. Refractory materials are marketed in a variety of forms, but bricks are the most common. Typical applications include furnace linings for metal refining, glass manufacturing, metallurgical heat treatment, and power generation. So there are also three kinds of refractories: fire clay refractories, basic refractories, and special refractories. So dito naman sa refractories is, ang mabibigay mo ang best example ito is yung mga furnace, which is na made of bricks na kaya niyang i-withstand yung high temperature. Yun. Tapos next, fire clay refractories. Fire clay refractories bricks are used principally in furnace construction to confine hot atmosphere and to thermally insulate structural members from excessive temperatures. For fire clay bricks, strength is not ordinarily an important consideration because support of structural loads is usually not required. Some control is normally maintained over the dimensional accuracy and stability of the finished product. So, sa fire clay is madalas lang ginagamit sa mga tulad ng mga furnace na yan. Kaso, ang kagandahan dito is kapag merong acidic gases na nangyari or material na nangyari sa loob ng isang blast furnace, is na-handle niya yun. Ayun. Next. Basic refractories. The refractories that are rich in perclase or magnesia are termed basic. They may also contain calcium, chromium, and iron compounds. The presence of silica is deleterious to their high temperature performance. Basic refractories are especially resistant to attack by slugs containing in high concentrations of NGO and CO and find extensive use in some steelmaking open heart furnaces. So, ang pinagkaiba naman niya dito sa una, which is yung fire clay, is kung yung sa fire clay ay na-handle niya yung mga acidic gases or material na nangyayari sa isang blast furnace. Dito naman sa basic refractories is kapag nagkaganon, is nagkameron ng acidic gases and material, is hindi niya kaya withstand yon. Hindi siya kasing ng fire clay refractories. Next slide. Tapos dito naman sa special refractories, yet other ceramic materials are used for rather specialized refractory applications. Some of these are relatively high purity oxide materials, many of which may be produced with very little porosity. Included in this group are alumina, silica, magnesia, beryllia, zirconia, and mullite. Others include carbide compounds in addition to carbon and graphite, silicon carbide, has been used for electrical resistance heating elements as a crucible material in internal furnace components. So unlike sa dalawa nating discuss, dito naman sa special refractories is kaya na magano ng mga electrical resistance at heating elements. Yun lang. Next slide. Abrasives. Abrasive ceramics are used to wear, grind, or cut away other material which necessarily is softer. Therefore, the prerequisite for this group of material is hardness or wear resistance. In addition, a high degree of toughness is essential to ensure that the abrasive particles do not easily fracture. Diamonds, both natural and synthetic, are used as abrasives. However, they are relatively expensive. The more common ceramic abrasives include, so dito sa abrasives naman is, ang ang pinaka-common nating makikita dito is yung mga sandpaper. Yung sandpaper. Ang abrasive, siya yung material na pwede natin siyang gamitin sa isang workpiece para i-polish or i-finish. Kaso lang, ang ano niya is, yung mismong abrasive is parang nato-turn up. Like, pag ginamit natin yung sandpaper sa plywood, pag gusto natin painisin yung plywood, gagamit tayo ng sandpaper. Tapos, pagkatapos natin siyang i-kiskes, makikita natin yung sandpaper is nawawala na yung kanyang pagka-rough. Ayun. Next, cements. Several familiar ceramics materials are classified as inorganic cement, plaster of Paris, and lime, which, as a group, are produced in extremely large quantities. The characteristic feature of this material is that when mixed with water, they form a paste that subsequently sets and hardens. Of this group of materials, Portland cement is consumed in the largest tonnages. It is produced by grinding and intimately mixing clay and lime-bearing minerals in the proper proportions and then heating the mixture to about 14,000 degrees Celsius or 25,500 Fahrenheit in a rotary kiln. This process, sometimes called calcination, produces physical and chemical changes in the raw materials. So dito sa cement is common din natin siya nakikita sa mga construction, tas sa mga gawa ng bahay, tas ito ang cement is siya yung nagbabayad ng mga materials into one, tas pinapatigas din niya yung mga materials na babayad natin. Next. Tas dito naman sa carbon, may tatlo siyang class. Diamond, graphite, and carbon fiber. Next. So, first is diamond. The physical properties of diamonds are extraordinary chemically. It is very inert and resistant to attack by a host corrosive media. Of all known bulk materials, diamond is the hardest as a result of its extremely strong interatomic splitter bonds. In addition, of all solids, it has the lowest sliding coefficients of friction. Its thermal conductivity extremely high. Its electrical properties are notable and optically, it is transparent in the visible and infrared regions of the electromagnetic spectrum. In fact, it has the widest spectral transmission range of all materials. The high index of refraction and optical brilliance of single crystals makes diamond a mostly highly valued gemstone. So alam naman natin na diamond is sa mga pinamatibay na material sa buong Earth. And sinabi nga rin dito ni is na napakataas ng kanyang thermal conductivity. Tapos, yun nga lang, sa downside ng diamond is napakamahal na rin. Ayun. Next slide. Graphite. Graphite is highly anisotropic property values depend on crystallographic direction along which they are measured. Graphite is very soft and flaky and has a significantly smaller modulus or elasticity. Its in-plane electrical conductivity is 1016 to 1019 times that of a diamond, whereas the thermal conductivity is 10,000. Furthermore, if we inverse the coefficient of diamond graphite's in-plane value is small and negative. and the plane perpendicular coefficient is positively and relatively large. Furthermore, graphite is optically opaque with a black silver color. So dito naman sa graphite is ang example na maano ko sa inyo is yung lapis. Yung tip ng lapis. Yun yung graphite. Tapos, unlike nga sa diamond na strong and durable, dito naman is siya ay very soft and flaky, which is kaya yung kanyang presyo is hindi siya ganun kataas. Next, carbon fiber. Small diameter, high strength, and high modulus fibers composed of carbons are used as reinforcement in polymer matrix composites. Carbon in this fiber material is in the form of graphene layers. Because most of these fibers are composed of both graphitic and turbostratic forms. The term carbon rather than graphite is used to denote these fibers. Of the three most common reinforcing fiber types used for polymer reinforced composite, carbon fibers have the highest modulus of elasticity and strength. In addition, they are the most expensive. So itong carbon fiber is alam na, ito yung sikat sa mga nagbabike eh, yung nagka-carbon lodi sa Bipetech. Yun yung carbon fiber is napakatibay niya, tapos napaka-durable pa niya. Yun yung kagandahan dito. Tapos flexible pa siya. Next. Tapos ang pinakahuli is ito, advanced ceramics. Although the traditional ceramics discussed previously account for the bulk of production, development of new and what are termed advanced ceramic has begun and will continue to establish a prominent niche in advanced technologies. In particular, electrical, magnetical, and optical properties and property combinations unique to ceramics have been exploited in a host of new products. Advanced ceramics include materials in electromechanical system as well as the nanocarbons. So, unlike sa discuss kong sa pinakahuli, ay sa pinakauna, itong advanced ceramic is ang pinagkaiba lang niya sa mismo ceramic is kung ang ceramic is nagamit siya ng organic compounds, ito naman is ang ginagamit niya is inorganic. Ayun lang. Next.
The microelectromechanical system. Microelectromechanical system, abbreviated sa MEMS, are miniatures smart system consisting of multitude of mechanical devices that are integrated with large number of electrical elements on a substrate of silicon. The mechanical components are microsensors and microactuators. The processing of MEMS is virtually the same as the use for the production of silicon-based integrated circuits. These, in, these include photolithographic ion implantation, etching, and deposition technologies which are well established. In addition, some mechanical components are fabricated using micromachining techniques. MEMS components are very sophisticated, reliable, and minuscule in size. One example of practical MEMS application is an accelerometer that is used in deployment or airbag system in automobile crashes. For this application, the important microelectronic component is a freestanding microbeam. MEMS sensors can be used to measure physical parameters such as acceleration, temperature, and pressure. Electronic components can be constructed on the same chip to measure the output of the sensors, perform signal processing, and provide wireless communication. Also, it can also handle high-frequency environment. However, the advantage of microelectric mechanical system is highly scalable in manufacturing, resulting in very low units when mass produced. MEMS sensors possess extreme high sensitivity, and the switches and actuators can attain very high frequency. MEMS are classically micro machined from silicon. Various types of silicon wafers exist, and silicon can be doped to varying conductivity levels. Additionally, functionally materials can be added to provide various capabilities such as electrode layers or piezoelectric layers. The nanocarbons, a class or recently discovered carbon materials. The nanocarbons have novel and exceptional properties, are currently being used in some cutting edge technology, and will certainly play an important role in future high-tech application. Three nanocarbons that belong to this class are polyrenes, carbon nanotube, and graphene. The nano prefix denotes that the particle size is less than about 100 nanometers. Before I discuss the graphene, the carbon nanotube, and fluorines, I want to share the carbon. What is a carbon dots? Carbon dots is are the interesting kind of zero-dimensional carbon nanometer with literal diameter of 10 with the lattice spacing of 0.21 and 0.34. The carbon dots and the polymer dots are different to each other. Carbon nanodots possess a graphite or amorphous-like structure, while the polymer dots consist of aggregated linear polymers or polymer chain around or inside a carbon core. The polyrenes. One type of polyrenes discovered in 1985 consists of a hollow spherical cluster of 60 carbon atoms. A single molecule is denoted by C60. Carbon atoms bond together as long as to form both hexagonal and pentagonal geometrical configuration. The term fuel- fullerenes is used to denote the class of materials that are composed of this type of molecule. Polyrenes structure is unique in that the molecule is borderless and change, has no boundaries, no dangling bands, and no unpaired electrons. This characteristic distinguish fluore- fluore- fluorescence from other crystal structures such as graphite or diamond, which have edges with dangling bands and electrical charges. However, the fluorines molecules are made of carbon atoms and their shapes are as hollow sphere. The carbon nanotube. Carbon nanotubes are also unique and structure sensitive electrical characteristics. Depending on the orientation of the hexagonal units in the graphene plane with the tube axis, the nanotube may behave electrically or as either a metal or a semiconductor. As a metal, they have the potential to use as wiring for small-scale circuits. In the semiconductor conducting state, they may be used for transistors and diodes. For carbon nanotube, have a outstanding physical properties such as high tensile strength, high electrical conductivity, and thermal, chemical, and mechanical stability. These physical properties can be increased by the functionalization and formation of components materials. The graphene. Graphene is the newest member of the nanocarbons, is a single atomic layer of graphite composed of hexagonal sp2 bonded carbon atoms. These bonds are extremely strong yet flexible, which allows the sheet to bend. Graphite is considered a semi-metal because it shares some properties with semiconducting metals. Free electrons in the graphite structure enable the efficient conduction of electricity, while the lack of electrons lead to high thermal conductivity. The graphene and the graphite are different to each other because graphite is allotrope of carbon having a high number of carbon sheet, whereas the graphene is single carbon sheet of graphite. However, graphene has much higher electrical conductivity than graphite due to the occurrence of quasi-particles which are electrons that function as if they have no mass and can travel long distance without scattering. These two characteristics of graphene makes an exceptional material. First is the perfect order found in the sheets. No atomic defects such as vacancies exist. Also, these sheets are extremely pure. Only carbon atoms are present. The second characteristic is relates to the nature of unbounded electrons. At room temperature, they move much faster than conducting electrons in ordinary metals and semiconducting metals.
Next naman po ay ang fabrication and processing of ceramics. So, sa fabrication and processing of ceramics, may tatlo tayong ceramic fabrication techniques. Una ay ang glass forming process, sunod ay particulate forming process, at sunod ay cementation. Ang ating tatalakayin ay yung una na glass forming process. Next. Glass forming process, ito man ay yung glass is produced by heating the raw materials to an elevated temperature above which melting occurs. Most commercial glasses are of the silica soda lime variety. The silica is usually supplied as common quartz sand, whereas sodium oxide and oxacalcium are added as soda ash and limestone. For most applications, especially when optical transparency is important, it is essential that the glass product be homogeneous and pore-free. Homogeneity is achieved by complete melting and mixing of the raw ingredients. Porosity results from small gas bubbles that are produced. These must be absorbed into the melt or otherwise eliminated, which requires proper adjustment of the viscosity of the molten material. So sa glass forming, may tatlo tayong nakapalob dito. Next nga po. Meron tayong different forming methods that are used to fabricate glass products. Una, pressing. Pressing is used in the fabrication of relatively thick-walled pieces such as plates and dishes. The glass piece is formed by pressure application in a graphite-coated cast iron mold having the desired shape. The mold is typically heated to ensure an even surface. Ang sunod naman ay blowing. Although some glass blowing is done by hand, especially for art objects, the process has been completely automated for the production of glass, jars, bottles, and light bulbs. Excuse me. Dito naman po, from a raw gob of glass, a parison or temporary shape is formed by mechanical pressing in a mold. This piece is inserted into a finishing or blow mold and forced to conform to the mold contours by the pressure created from a blast of air. Yun ang blowing. Next naman po ay Lastly, drawing. Drawing is used to form long glass pieces that have a constant cross-section such as sheet, rod, tubing, and fibers. Next.
Fabrication and processing of clay products. As we all know, raw materials usually have to go through a milling or grinding operation in which particle size is reduced. This is followed by screening or sizing to yield a powdered product having a desired range of particle sizes. For multi-component systems, powders must be mixed with water and perhaps other ingredients to give flow characteristics that are compatible with the particular forming technique. So para mas maintindihan natin, let me discuss this one by one. We have hydroplastic forming, slip casting, drying and firing, powder pressing, and tape casting. Next po. So, hydroplastic forming. The most common hydroplastic forming technique is extrusion, in which a stiff plastic ceramic mass is forced through a die orifice having the desired cross-sectional geometry. It is similar to the extrusion of metals. For example po ng hydroplastic forming is brick, pipe, and ceramic blocks and tiles. Usually, the plastic ceramic is forced to the die by means of motor-driven auger, and often air is removed in a vacuum chamber to enhance the density. Hollow internal columns in the extruded pieces, for example, is building brick, are formed by inserts situated within a die. So, ang advantage po ng hydroplastic forming is simple, efficient, and cost-effective, suitable for mass production. And meron din po siyang disadvantage, which is the limited to shapes that can be formed to a die. Next po. Second is sleeve casting. Another forming process used for clay vase composition is sleeve casting. So, sleeve casting, also known as liquid casting, is a widely used for forming process for shaping clay vase compositions, particularly for creating intricate and delicate ceramics objects. A sleeve is a suspension of clay and other non-plastic materials in water when poured into a porous mold commonly made of plaster of Paris, which water from the sleeve is absorbed into the mold, leaving behind a solid layer of the mold wall, the thickness of which depends on the time. This process may be continued under the until the entire mold cavity becomes solid. So as we can see in the figure, the sleeve casting process can be employed in two primary methods, which is solid casting and drain casting. In figure A is solid casting. The sleeve is allowed to remain in the mold until the entire mold cavity is filled with a solid layer of clay. This method is suitable for creating solid ceramic objects with no interval voids. In figure B is drain casting. The excess sleeve is poured out of the mold after a predetermined time, leaving behind a layer of clay on the mold's inner surface. The thickness of this layer determines the wall thickness of the final ceramic piece. Drain casting is particularly useful for creating hollow ceramics objects such as vases, bowls, and cups. So, ang ibang example po ng sleeve casting is yung mga decorative items po, tulad po ng mga sculptures, ornaments, and sa technical ceramics po is yung mga electrical insulators, laboratory equipment, and refractory materials. So, next po. Dyeing and firing. A ceramic piece that has been formed hydroplastically or by sleeve casting retains significant porosity and has insufficient strength for most practical applications. In addition, it may still contain some of the liquid. Example is assumed water that was added to assist in the forming operations. This liquid is removed in a drying process. Density and strength are enhanced as a result of a high temperature heat treatment or firing procedure. A body that has been formed and dried but not fired is termed green. Dyeing and firing techniques are critical inasmuch as defects that ordinarily render the wear useless. Example is warpage, distortions, and cracks that may be introduced during the operations. These defects normally result from stresses that are set up from non-uniform shrinkage. So, the madaling sabi, drying is the process of removing moisture from the formed ceramic pieces. And the firing is the process of heating the ceramic piece to high temperature to harden it and remove any remaining moisture or organic matter. So to prevent the defects during drying and firing, mahalaga pong tandaan na kailangan natin na gamitin yung consistent forming technique and control the drying rate carefully. Use a slow, even firing schedule. Avoid exposing the ceramic piece to sudden changes in temperature. And also use high quality clay and glaze materials. Next one. So powder pressing. Another important and commonly used method that warrants brief treatment is powder pressing. Powder pressing is the ceramic analog to powder metallurgy. It's used to fabricate both clay and non-clay compositions, including electronic and magnetic ceramics, as well as some refractory brick products. In essence, a powder mass usually containing a small amount of water or other binder is compacted into the desired shape by pressure. So the degree of compaction is maximized and the fraction of void space is minimized by using coarse and fine particles mixed in appropriate proportions. There is no plastic deformations of the particles during compactions as there may be with metal powders. So the additional info, there are three basic powder pressing procedures, which are the uniaxial, isostatic, or hydrostatic, and hot pressing. For uniaxial pressing, the powder is compacted in a metal die by pressure that is applied in a single directions. For isostatic pressing, the powdered material is contained in a rubber envelope and the pressure is applied isostatically by a fluid. With hot pressing, the powder pressing and heat treatment are performed simultaneously. The powder aggregate is compacted at an elevated temperature. Next po. Next po. Tape casting is, a, is an important ceramic fabrication technique. As the name implies, in the technique, thin sheets of flexible tape are produced by means of casting process. These sheets are prepared from slips in many respects similar to those employed for slip. This type of slip consists of a suspension of ceramic particles in an organic liquid that also contains binders and plasticizers which are incorpor- incorporated to impact strength and flexibility to the casting. The airing in a vacuum may also be necessary to remove any entrapped air or solvent vapor bubbles, which may act as crack initiations site in the finished piece. So tape casting is widely used in the production of ceramic substrates that are used for integrated circuits and for multi-layered capacitors. Next po. Lastly is the cementation. Cementation is also considered a ceramic fabrications process. The cement material, when mixed with water, forms a paste that, after being fashioned into a desired shape, subsequently hardens as a result of complex chemical reactions. So this process is often used for mga manufacturing products po like refractory bricks, abrasives, and dental restorations. Yun lang po. Thank you.
Okay, so tapos na po ang group ng ceramics.
Yes po, ma'am. Tapos na po.
Okay, so thank you po sa inyong presentations po. Meron po ba kayong tanong about po sa ceramics? Meron po? Wala naman po. Hello? Wala? Okay. Bali, next, ngayon na po ako magdi-discuss din. Hindi ko kasi alam kung baka mahaba po yung discussions po ng polymers. So, bali, next week po is schedule na po natin ng experiment. Bali, yun po ay yung paggamit po ng tensile testing machine po. So, ang schedule nyo po ay, di ba 10 to 1? Meron ba kayong klase ng 8 to 10? Meron po kayong klase before po sa akin?
Wala po.
Okay. Pwede ba na mas agahan po natin yung pag-experiment po? Pwede po ba tayo ng 8 to 12? After ng klase niyo sa akin, saan po kayo sunod? May klase po kayo sunod after po ng klase sa akin?
Bali, answer po ang next. Alas 4 po.
Alas 4 pa. So okay lang pala tayo na kaya lang kasi ma-occupy natin yung lunch break sa office ng 12 to 1. Okay lang po na agahan po natin ng kaunti. Gawin natin ng 9. 9 to 12 and then 1 to 2. Okay lang? Ano po?
Okay lang po. Pero tatanungin po sa
Okay. Pasabi ako ininga o kaya naman po ay 8 to 12 para dire-diretso na po tayo. Okay?
Okay po.
Ako naman ay presentations lang din po ako sa O7 kaya pwede pong habang nag-experiment ay nakikinig po ako sa kanila. Yan. So, ganun na lang gagawin natin. 8 to 12 or kaya po ay 9 to 12 and 1 to 2 para Yung lunch break kasi ng technicians at saka po nung sa office doon ay para meron po tayong lunch break. Ano po? Face-to-face ba yung inyong klase? Na ng alas 4? Hello? Face-to-face po ba?
Face-to-face po. Pero depende
Ah,
na po sa sir.
okay po. Yan. So, since face-to-face naman po, gano'n na lang din. Mag-iintay lang din naman po kayo dito. Ano po? Okay lang na 1 to 2 yung iba. 9 to 12 and 1 to 2 or 8 to 12. So, sabihan nyo po ako ha kung ano po yung mapag-desisyonan nyo. Ano po? Ano po? Then next, and then, bali ang magiging hatian po natin ay hindi po lahat agad pupunta. Ano po? Ang unang group po na pupunta ay yung group 1 to 3. Ano po? And then, after nun, ay yung sunod na po ay 4 to 6 po. So, bali, ang mangyayari po sa ating experiment ay di isa muna po ang mag-experiment. Tapos, yung iba po, nandun sa may, nakita nyo yung malapit sa may gym na upuan. Hello. May mga upuan doon yung pagpasok po. Bago mag-gym. May mga upuan po doon. Hello. Hello po.
Yes po. Aba, ma'am.
Tapos na. At, okay. Doon muna po kayo titigil yung mga hindi po mag-experiment. Bali, 8, halimbawa 8 or 9 po tayo mag-start. E di, una muna po ay group 1, tapos ay sunod ay group 2, group 3. So, bali, ang schedule po ng 1 to 3, kung sakali po ay yung first 2 hours. Pero tapos yung sunod po, yung sunod po na 2 hours po ay para sa 4 to 6. Pero yung group 4 po, kailangan mas maaga po siyang pupunta kasi baka madali pong matapos. Ano po? Madali pong matapos yung group 4. So, yun ay sunod-sunod na po. Pagkakatapos ng isa, yung sunod naman po ang mag-experiment. Naintindihan ka po? So, kaya kailangan po ay lahat po ay nandun during the experiment, yung lahat ng group. Ano po? So, pag nag-experiment po tayo next week, Tuesday po yun, kayo po ay naka PPE. Ano po, ang magdadala po kayo ng, hindi naman po lahat, depende po kung sino yung mag-ooperate. So magdadala po kayo ng gloves. So kahit isa lang po. Gloves, goggles, at saka po, magdala na din po kayo ng face mask ha. Lahat po ay magdadala ng face mask. And then, dapat po ay naka-rubber shoes, naka-pantalon, at naka-t-shirt or polo shirt po. So, papapasukin naman po kayo kapag naka-white at saka po naka-org shirt. Tama ka po. Hello. Hello po.
Yes po, ma'am.
Yan, so ganun na lang po yung inyong magiging susuotin ha para mas safe po tayo. Tapos wala muna tayo. Pag mag-experiment na, tatanggalin muna yung mga ID lace. Ano po? Any questions po? May tanong pa po ba kayo? O may tanong po kayo sa mga nag-present? Wala po. So, paki-lista po ako ng mga gusto niyo pa pong i-discuss natin about po sa metals and ceramics para sa week 16, i-discuss ko po yung mga yon. Ano po. Kaya lang, nga pala, ang week 16 nga pala ay parang foundation day na walang klase. Pero baka po tayo ay, hindi ko alam kung pwede tayo magklase, pero sana makakapagklase po tayo ng week 16. Kasi week 17 na po ay, exam. Baka exam na tayo ng 17 or 18. Ano po. Yan. So, di ba sa week 13, ngayon po ay presentations ng 3. Week 14 po yung experiment. Yung 2 hours po natin, gawin na lang din po natin yung na presentations ha. Kasi sayang po yung magiging oras natin. para pag sakali man po na hindi na po makapagklase, hindi na payagang magklase ng week 16 ay matatapos natin. Ano po, matatapos natin yung coverage po. Ah, so, may tanong pa po ba kayo? May tanong po? And then magdadala nga pala kayo kahit isa lang po sa isang section po ng caliper and metro po. Naintindihan? Okay. So, yun naman pong halimbawa ay gloves, goggles. So, pwede naman pong mga dalawa lang po sa klase kung payag po kayo na maghiraman. Pero kung ayaw nyo naman po maghiraman, edi magdala po kayo ng kanya-kanya. Ano po? Okay? Be sure nadala nyo po ang specimen. Cut na siya. Ano po? Ang diameter is 10, 12, and 16 mm with a length of 460 millimeter. Ano po? Naintindihan?
Yes po.
Yan, okay po. Yan. So, ang next group po ay sa next meeting na po magpe-present bukas na lang po kasi kulang na din tayo ng oras. So, kung wala na po kayong question, makiki-open po ako ng camera at tayo po ay mag-attendance po. Sino pong pwedeng mag-screenshots? Makiki-open pa ako ng inyong camera. Meron po ba dito nandito ba yung hindi nakakuha ng exam? Wala po. Sino po mag-screenshots po? Sino pwede? Sige. Miss Enriquez.
One, two, three. Okay na po.
Okay po. So, kung wala na po kayong tanong, pwede na kayo mag-leave. So, yan. Ingat po.